Hello, everyone. Thank you for joining us today. We'll get started in just a moment. I'd like to introduce you to today's webinar on moving Amazon Web Services, presented by Percona's Solutions Engineer, Dimitri Van Orbeek. I just want to do a little bit of housekeeping. If you can just raise your hand to let me know that you can hear me using the hand icon tool located in the GoToWebinar panel. Perfect. Next, during this webinar, you will be on mute. Should you have any questions during the discussion, please enter them in the questions field within the control panel. At the end of the webinar, we'll take time to answer as many questions as possible. Those that aren't addressed will be answered in a follow-up blog entry on Percona's database performance blog. In addition, a recording of this webinar will be made available to everyone within 48 hours or less, along with the slides. With that said, I'll turn the floor over to Dimitri.
Okay, perfect. Hello, everyone. So let's start. So today I'm going to talk about AWS, its functionalities, and how you can migrate to them. So I'm going to start a little bit with talking about myself. Maybe that might interest you. So I'm a solution engineer within Percona, which means that I talk to a lot of customers. I discuss our services, our offerings, technologies. I have multiple discussions with them, and typically I align our services to what their needs are. Prior to Percona, I've been working as an open source system integrator in multiple jobs, which were in telematics, in government entities, or in universities. So my strong suits were and are MySQL, Puppet, and General Linux. And I'm a Belgian, like Dr. Evil, located in the city of Ghent. Belgium is renowned for its chocolate, waffles, and beer, of course. And I'm known as Dimo if you're looking for me on Twitter. So let's start today. So what is AWS? So I'm going to first go a little bit on a high-level introduction, and then we can go deeper inside each technology. So AWS is an acronym for Amazon Web Services. Amazon likes the short terminology words, and typically they mean something different, each one of them. So it's a division of Amazon.com, which originated as a book retailer, but now even sells food. It operates as a set of connected services. So it's actually made on a surplus of what they were previously using for their services internally for the Amazon store, and they made a lot of services which are now available as a public cloud solution. So the most popular ones are EC2, RDS is very popular, but also, for example, the identity management is definitely interesting. What you have to keep in mind with Amazon Web Services specifically is that everything is a service. So EC2 is, for example, infrastructure as a service, and RDS is database as a service. So, of course, why could you use AWS? Because AWS is a very popular offering, especially in the public cloud services. So one of them is, of course, why is AWS so interesting is because it's very easy to configure and deploy. It's just, first of all, the first time you set it up, it's just asking for your credit card details, and immediately you can start playing with setting up environments, setting up services. And they're often used in a startup mode, but also in mature companies. They make sure that you have a fantastic way to have infrastructure without really having to host it yourself or having on-premise hardware. It's also often used because it's one of the most popular ones, and also one of the first ones that actually offered a public cloud offering for typical CIOs, which will actually push your team towards moving towards, for example, AWS. There is no high step-in cost. You pay for what you use, so costs are incremental. It depends a little bit on how much you will use, how much bandwidth you will use. In a way, it can add up at a certain point, but it's really focused on giving you as much value dependent on what your needs are. You can also limit the amount of systems based on usage. One of my first jobs on AWS, that was back when I was an open source integrator, was actually on auto-scaling, for example, Java application servers, making sure that if response times were slow or if the amount of connections rose, that additional systems were actually added inside a Terracotta cluster. And it would offload them, and it would actually destroy instances the moment that they were no longer useful. You also don't need to do infrastructure management. It will give you less worries, but that's, of course, if all works well, right? So not during an outage. But what the good thing is that you don't have to worry about the underlying hardware. Why shouldn't you use our AWS? Well, I think if you're on this webinar, probably you have a certain interest in it. But if you want to get your hands dirty yourself, if you like switches, if you like replacing RAID controllers, if you enjoy playing with SAN enclosures, maybe AWS is not the forte, is not your solution, the solution for you. Also, if you don't trust external partners maintaining your infrastructure, keep in mind that the cloud, as some people say, is actually working on other people's computers. So if you have a cold sweat nightmare about the lack of visibility that you have using a cloud provider, public cloud provider, at that moment, maybe AWS is not really the solution for you. Also, if you have really extremely stringent availability concerns, it might be more interesting to take a step back and rethink what type of architecture you would really need before really opting inside AWS. What you have to keep in mind, however, is that typically public cloud solutions have a better uptime than your own infrastructure. So it depends a little bit. Of course, looking back at the outage that Amazon had in February 28, I believe, issues can still happen on a public cloud provider, even user issues. So what will we discuss today? First of all, Amazon EC2. What is it? How can you migrate towards EC2? Also, we'll go a little bit deeper on Amazon RDS and also the migration options you have to move towards it. I will also discuss a little bit of frustrations that you might have with Amazon RDS because there are some limitations that you have to keep in mind. I'll also discuss and cover a little bit on Amazon Aurora. We'll go high level about what it is, why you would want to migrate towards it, and also how you could migrate towards it from an existing infrastructure, either in RDS or externally. So Amazon EC2, what is it specifically? So it was sold as elastic compute capacity. So I don't know if people know a little bit about OpenStack, but you could compare it a little bit with Nova. So it's actually a virtual server with attached storage. And the good thing is that it provides you, for example, an OS or a service, depending on what type of Amazon machine image you're using. But you can essentially install, for example, in regards to databases, MySQL, MariaDB, Percona server, any blend of clustered solution. And you can actually mix also, if you want to do that. It's not a best practice in my opinion, but you can mix database service, for example, with application servers running a Tomcat locally. So it's really like having a server, but located in the cloud. The operational management, however, for all those services is still performed by your team or external, which means that, for example, if you have to upgrade your MySQL version, it's still something that you will have to prepare, which you will have to test and make sure that it's put in production. You can perform monitoring using Amazon's CloudWatch itself, or external services if you want to, for example, to use if you use database servers like MySQL or MariaDB, you can use PMM, you can use Vivid Cortex, you can use Cluster Control. Yeah, you have the whole array of solutions. You can even actually set up your own Nagios internally, if whatever your favorites are. It's also Xen based for the guys who still remember Novel, and actually that's the hypervisor technology behind it. So when should you use Amazon EC2? First of all, in my opinion, you should use it when you have DBAs and sysadmins in-house. And why is that? Because it gives a lot of flexibility to your DBAs, and also a lot of control. Of course, with control comes responsibility. So it means that you need to have people who are able to manage MySQL database solutions. The good thing about it is that you can actually use Galera or Extra Backup, Percona XDB cluster, whatever. You can actually use whatever blend you would prefer. Compared to the other ones, so for example, RDS and Aurora, it's also a solution which is easier to troubleshoot. You can actually deep dive internally to see what's happening on your MySQL infrastructure. And items are quite, well, especially it's much easier to interpret values if you can actually access them easily without having to go through an API. It also has a lower cost than Amazon RDS, but of course it has a higher operational cost because you will actually have to work on it, maintain it, etc. So time is also money for your engineers. The good thing, in my opinion, of course, is that you can install Percona Server, which is an optimized version, and you can actually install very old versions of MySQL. You can go back to 4.0 if you want. Or even earlier. I would not advise it, of course. So EC2, very simple example architecture. Why? Because it's your choice. It's your infrastructure. It's your hardware. Well, it's not your hardware, but it's your virtualized server that you can actually use and misuse for whatever your reason you want. So you can have master, multiple slaves. You can have Galera cluster. So migrating to Amazon EC2 is not something which is very difficult because you could see it as actually migrating towards another data center with your own local storage, local database servers, or you could see it as adding database servers inside your own infrastructure. So what you could use, what we typically recommend using, what I recommend using anyway, is using Percona Extra Backup to populate the new Amazon EC2 machines that you want to use. What is good about Extra Backup is it's non-locking backup for InnoDB storage engines, and it supports also the MyISM storage engine. You create a new slave for your current MySQL environment, which will actually replicate from the current master, so your system which is currently in your premise, and then switch over, which is actually typically will create only a limited amount of downtime, which means that potentially you just have to repoint your application or add in, for example, change your load balancer if you use specifically a load balancer inside your current database infrastructure. Theoretically, you could even use Percona XDB cluster to add in nodes. I would not recommend it, but it's a possibility. So it's very easy, right? So typically what you do is you dump from your slave, you re-import that on your new master on Amazon EC2, and then you point your current system, so your current master on Amazon EC2, to replicate from the current on-premise hardware master. The idea is that you replicate and then actually repoint your application towards the new infrastructure on Amazon EC2. What you have to keep in mind is that typically those types of migrations don't come alone. So typically people will want to migrate also their application servers. They also will want to migrate their load balancers immediately to the Amazon cloud. Keep in mind that even with Amazon EC2, even if it's just virtual hardware, is that you will still need to check if for example, the performance is consistent enough, if the performance is correct for what your expectations are of the hardware. So still make sure that you perform regression testing, application testing, and that you actually verify that also through load testing that the new master slave environment is working as you were expecting. A lot of people are using this type of setup, moving towards EC2. So let's jump to Amazon RDS, because that's actually, I think, where most people are actually currently join in for this webinar. So Amazon RDS is a relational database service. So it's a database as a service solution, which is something which offers you the ability to easily spin up, for example, new database servers, remove them, scale them potentially. It's actually also something which provides you with a service, a MySQL. You can actually connect directly to the database server and perform tasks on it. So as it was one of I think the first one that actually came on the market from a public cloud solution hosting solution provider, and it is actually active since 2009. Since then, you now have in RDS Oracle database, Microsoft SQL, Postgres, and also recently MariaDB. It provides you with a complete graphical user interface, which is interesting, especially as a step up, because it requires you to have less specific internal knowledge if you, for example, have to configure yourself your MySQL database. It's really easy to spin up a new machine. It's also easy to manage it and to create, for example, backups, etc. for them. Maintenance and updates, and that's something that you will immediately opt in or opt out the moment that you create the system itself, will be performed during a predefined moment. And what you have to keep in mind with maintenance and updates are, for example, minor updates, security updates on the underlying hardware, because those types of things also happen. In a way, RDS is based on EC2 on itself, right? So it's actually on top of EC2 internally. So some competitors of Amazon RDS are, of course, Oracle Cloud, Rackspace Cloud databases. Also a very popular one these days is Google Cloud SQL, which is also a database as a service provider. So what is it also more in detail? It's a fully managed MySQL database environment. So you don't have to provide your own hardware or your own, you don't even have to create it yourself on EC2. It provides also support for multi-AZ. What is multi-AZ? It's the high availability solution, which is included in Amazon RDS. It's an option that you can activate. It has an associated cost with it. But what it actually does is it actually performs on a file system level synchronization, a synchronous replication towards another availability zone, and it makes sure that you can actually fail over it. You get an endpoint which you can connect to, and that endpoint will actually automatically move towards the failover master in case that something breaks. It also has support for read replicas. Read replicas are comparable to a synchronous replication. It's also based on the same technology. We're talking about something that will just replicate from the current master. It can also fail over potentially to a read replica. You can actually promote a read replica to become a new master, in which that it will disconnect from the current master. Also, it will perform backups daily. You will have to say how long the retention period is, but you can actually also perform backups and point-in-time recovery of the current database environment. So what is really important with Amazon RDS itself, though, is that you can easily scale it. So you can actually modify the instance size using just a drop-down list during a modification, and it will modify its instance during the maintenance window or immediately, depending on what you want. You can monitor, of course, it using PMM and Vivid Cortex, and there's actually quite interesting documentation how you can integrate it with PMM. So when should you use Amazon RDS? I would say if you want to outsource the engineering around creating a MySQL infrastructure. So your system engineers and DBAs can be working then on other jobs, other tasks, research and development items, which are much more interesting sometimes than having to maintain a current running MySQL database. Also, if you have scalability concerns, for example, you're in a startup phase and you don't know how quickly your environment will grow in the next month, it's always difficult to order the right hardware immediately. Will you over-order and make it a very costly experience? Maybe that's not the most interesting interesting choice. With RDS itself, you can actually choose to go from a lower end system or instance towards a higher end instance. Also, if you have high availability concerns, it's an interesting one because building a high availability solution can be sometimes a very complex thing to maintain and engineer. And the standard DRBD type solution that they are offering is offering you a high availability solution, which will make sure that you can actually repoint in a couple of minutes, or the system will be back active in a couple of minutes, and it will make sure that you can actually continue your transactions easily. So if you can handle those couple of minutes of downtime, something like multi-AZ will be actually a good type of solution for you. Also, of course, when should you use our Amazon RDS is, of course, to save time, because it's easy to spin up. You don't need to do the ordering or reinstalling everything on EC2. And also, of course, if your manager said that you have to move to the cloud, it's an easy solution for that, potentially. When would you want to avoid using Amazon RDS? So specifically also, if you're already experiencing performance issues on your current hardware, on your on-premise hardware, it might be not the best idea, because it's sometimes very difficult to tune your MySQL interface for specific workloads, because you only have limited amounts of modifications that you can put in place. Also, there's a limited diagnostics capability inside RDS itself. There's no direct access to the infrastructure, and you cannot verify the logs easily. If you need active synchronous replication, so if you need a different high availability solution because you want master, for example, at that moment, RDS is not something which is actually plausible for your environment. Also, in my opinion, if you want a hybrid solution with multiple data centers, one external, one internal, it's not the best solution. So, some limitations in RDS. So that's actually a page based on the best practices that RDS actually recommend. So, in their opinion, they're limited to 10,000 tables if you're using provisioned IOPS. They're also limited to 1,000 tables if your database is smaller than 200 gigabytes, which is already a decent size in my opinion, or have standard storage. So that's important to know. The moment you go over these numbers, Amazon recommends you to move to one InnoDB tablespace. Standardly, as a default option, InnoDB file per table is set on 1, which means that for each table you will get your own InnoDB tablespace. Also, a hard limit is on the size of the instances. So the maximum size that you can have is 6 terabytes of data at this point. So current generation of Amazon RDS DBs available. Well, you can probably see them on the website. Probably my list is not even updated correctly to them. But what you have to keep in mind is that standard generation is good for general workloads. Memory optimized generation is something which is interesting, especially if your working set is, you need really high performance, so high performance changes, a lot of writes, etc. And it can fit inside memory. At that moment, I think the memory optimized generation is really interesting for you. The cheapest one are the burst capable generations. In my opinion, that's mostly used for baseline performance. So some items to keep in mind. So make sure that you use provisioned IOPS. And why is that? Because you want consistency. You don't want your neighbors to influence your performance. And why is that? Because if your neighbors are having peaks and you don't have provisioned IOPS, potentially your IOPS will actually drop together with them. It's comparable to having a hypervisor on local hardware, on your local premises. So make sure that make sure that you use provisioned IOPS, because at least you will be able to have consistency on the storage level. Also, make sure that you do either automated updates or not, depending on if you can actually handle the downtime or the failover. But make sure that you perform, in my opinion, performing automated updates is always a good idea, but in some circumstances it's not a good option. So make sure that you verify what your best option is. Make sure also that you have read performance, right? So use your read replicas. Why? Because you can offload your select queries to them. And if you're not using that right now immediately on your infrastructure as it is, in my opinion, it's already something important to look at. If you can actually separate part of the reads towards your slaves. It's comparable to master slaving on EC2 or on physical hardware. Also use VPCs because you want to separate the network on your RDS, and that's sometimes very interesting, specifically for compliance reasons. Some items to keep in mind before that you actually migrate towards RDS. So make sure that your current infrastructure, and that's because some people who did actually migrations for Percona for customers towards RDS mentioned that, for example, if customers are using local time zones for their application instead of UTC, it might be painful for their application to work on RDS because RDS is standardly using UTC as the time zone. Also, the max allowed packet is default pretty low. In MySQL 5.6, for example, as a standard default, it's 16 megs. However, on all my RDS test infrastructure, it was 4 megs, and I know previously it was even lower. And when can this be very, very important is the moment that you're actually doing the migration. So when you're doing your dump and import of the data itself, it might be important that you're actually heighten that value. You have to also call out Amazon design functions if you want to kill queries or other administrative actions. And that's something very important to know. You don't have super on Amazon RDS. You don't have super privileges. So a lot of functionalities are actually protected again. Well, you're actually protected against using them. You can download the logs, so you don't have physical access to the system itself, but you can actually use the API to immediately automatically download the logs and, for example, use PT Query Digest on the slow query logs. There is, of course, a possibility to do it through the graphical user interface, download it, but in my opinion, that's just, it takes some additional work to do that. So important is you don't have root nor super privileges. So of course you can do a show process list, but what if something breaks? If you see, for example, some queries that you want to kill, well, there are some functions that you can call. So for example, MySQL RDS kill query. Also, which is actually something that only works if you have super privileges. Also, you can actually not create have an external master without having super. So, for example, change master to wouldn't work on Amazon RDS. It would fail immediately. So you would have to call specifically an external script. There are some optimizations in there which are interesting. For example, that you can actually dump the buffer pool and actually reload it for performance standpoint, so that you can actually make sure that the system, when it's started up, that you can actually have decent performance immediately on the buffer pool that's already propagated. And there's also, because binlog retention is pretty low as a standard on Amazon RDS, you have a function to grow that, so you can actually modify the configuration itself using RDS set configuration. There are some interesting documents available on that, especially written by the AWS team, the RDS team, which are interesting to look through, especially to see what options and what functions you can actually use. Also, when dumping an existing database, due to the absence of the super privilege, you cannot simply create new triggers. As in normal MySQL, you don't have the super privilege, and binary log. Well, actually, it's enabled, but you need to add in the log bin trust function creator. So you have to actually activate that, and this is the error message that you will get when you try to add a trigger standardly. So you will have to create a DB parameter group, and that's important to know within Amazon AWS. It's not just set global, modify your variables directly. No, you have to make sure that you create a database parameter group, and you can do this through the graphical user interface or either to the CI, so the console interface. So what you want to do is definitely dump your information without the triggers and the routines, because if you're going to import that, this is going to fail, and potentially your MySQL import will fail completely. And that's not bad if the database is 200 megs or a couple of gigs. But the moment that we're talking about very large databases, it would cost you a lot of time potentially to re-import everything. So um, backups with RDS are pretty simple. So you have Amazon snapshots, which actually take only work with InnoDB. If you want to do it with IISM, keep in mind that they will be corrupted if you use snapshots. So try to limit yourself to InnoDB when you're using RDS. And the default retention period for Amazon snapshots is only 7 days. That can be enough. Some people will need to raise this, but that's a value that you could modify easily inside Amazon RDS when you create the instance or modify it. You can also use MySQL dump or MyDumper. The moment that you're going to use it on a read replica, because you potentially need to log the databases to make sure that you log the table so that you can make sure that it's actually potentially consistent. So how would you want to migrate towards Amazon RDS? So you can, of course, standard dump and import procedure. You will have to create your own triggers and store procedures afterwards. Try to dump it without the routines, with min routine 0, trigger 0, event 0. And make maybe use force if time is of the essence. So, of course, if your database is not that critical at this point, and your on-premise database can handle downtime, well, you could use that procedure. If you want to limit the amount of downtime, potentially you want to replicate to Amazon RDS to import actually and to maintain the information. So what you typically want to do is dump first the information, make sure that you have a consistent backup using single transaction on the current infrastructure, and then push it towards an EC2 instance. Then import all the data through that EC2 instance towards your MySQL RDS. I will go for a graphical visualization, which is a bit more clear. But the idea in the end is that you replicate externally from an external master towards your Amazon RDS system. It's comparable to replicating towards an EC2 system. But the idea is that you can limit downtime to your MySQL database infrastructure. Keep in mind that no version earlier than 5.1, and if you have 5.1, that you have to replicate to 5.5. Why is that? Because that's the standard how you can replicate, actually, that's the standard replication process that Oracle advises to migrate towards major versions. Again, if you're migrating towards a newer major version, keep in mind that you first want to, before that you go live or you do the actual switchover, that you confirm that the load expectations are correct for you, that you can actually test the environment, that you're sure that it will work, do regression testing, make sure that you do applicative testing, etc. So for the migration with replication, make sure that you use MyDumper maybe, because that can do it in a multi-threaded way. Use MyLoader or MySQL import to import the information. I would recommend that you use an EC2 machine to import the information on the actual RDS system to make sure that you limit network bottlenecks or actually connections failures, etc. Also, that you verify after you've imported the information the consistency of the database environment. So make sure that you do consistency checks. Also, after that, you actually do modified that you actually have a replication running on the RDS environment. Make sure that you verify consistency. Do standard verification. Check your character set and also verify if your load will work. So this is the graphical example, right? So in this case, I use the master again. Again, feel free if you're sure about the consistency to use your slaves. Use MyDumper of MySQL dump, and you create your files. Your queries are still being actively used on the master, and what you will actually, and you already have set up a new RDS environment with 2 read replicas. So what you will do is actually import data on an EC2 machine through an EC2 machine. Theoretically, you can also do it direct, but that's something maybe you want to avoid. But towards the active master, and that will propagate itself to the read replicas, right? So you will make sure that your data, your backup is actually imported on the active master and its read replicas. Next to it, your queries will still run on the current master, right? So you don't see that here, right here, but it's still same case, right? So at that moment, what you want to do is make sure that your slave, your Amazon RDS environments, which is actually the master inside the RDS environment, but is actually going to be the slave of your current master. So you want to make sure that that's up to date. So you want to see that the slave, the replication lag is actually 0. So at that moment, your queries are still running towards the current master. So you can actually do your consistency checks, do verification of if the data is correct, but also next to the consistency checks, verify, for example, if performance is comparable. You can do complete applicative testing. Potentially, you can redo the backup and restoration, depending on how far you want to go with your consistency checks. You can separate one of the read replicas, promote them to master, and do complete applicative testing on it also. So you have all these options. Make sure that you use them. And then if you're 100% sure, you just start so you need to you will still need some downtime, but minimal downtime, to actually fail over the right queries or the modification queries towards the active master. So that means that your application potentially needs to move its endpoint. Of course, I would still, in my opinion, it's best that your application is then also residing inside the Amazon data center. But that's not how you call it, obliged. Of course, now you migrate it to Amazon RDS. And Amazon RDS is a nice technology, but maybe at a certain point in time, you want to move away from it, right? So in my opinion, what you have to do is, prior to moving towards RDS, is to be, in a way, sure that you want to take that step. So again, make sure that your business requirements match the expectations that you can have from Amazon RDS in regards to uptime, failover, performance. And then if in the case, for example, in a couple of years you say, okay, well, I want to go away from RDS, you can still replicate from RDS to, for example, an EC2 machine or even a completely external machine. But what you have to keep in mind is that you will have to go towards the same painful process. Dump and restore the data of using MySQL dump. But there is some interesting documentation available to this, and I know that several knives actually created a blog post this week on it, which actually goes a bit deeper on moving back to your own server, because that's also something which is typically, well, forgotten. It's all in regards to opting in within RDS. It's a very interesting, very powerful solution, but maybe at some point you want to regain control and actually be flexible again to choose your own type of technology, like Percona HTTP cluster or something else, to make sure that, for example, you have master-master capability, or to have well, a less than a couple of minutes failover solution. So that's reiterating on RDS migration process a little bit. So in regards to Amazon Aurora, so Amazon Aurora is a new silver bullet, a little bit developed by Amazon, which is in a way a MySQL compatible RDBMS engine. So it means that actually you can use the same type of SQL queries on MySQL than on Aurora, for example. Or on RDS and on Aurora. The good thing about it is that it replicates data in multiple availability zones, and it does it on a special way. It's something quite custom, because it's actually using an object store functionality. So it's actually using its storage system to propagate actually changes immediately to the other nodes. From a functionality standpoint, you can actually see on a high level that it's somehow comparable on consistency, etc., to Galera or other cluster solution. In a way, it's different also. right? Especially the implementation completely different. In a way, you could see it a little bit like MySQL together with Ceph or another solution, in which that it actually has object stores where data resides, and that's actually replicated towards each system. Well, towards the data itself, and the nodes internally are communicating only the redo logs towards it. So it's a special blend, in my opinion. At this point, it's only MySQL 5.6. I know they're announcing to have 5.7 available, and I know they're working on it, but it's something for the moment that's only available in MySQL 5.6. What is important with Amazon Aurora, especially the moment that you're using it, is that you have to use endpoints to guarantee the level of high availability. You don't connect directly to the system itself. It's comparable to RDS on this perspective, in my opinion. So you make sure that you're using the cluster endpoint or the reader endpoint, depending on what type of queries you're sending out. The good thing about Aurora, and that's especially for the people who are now currently on running RDS, having 4 terabytes or 5 terabytes of data, and they're worried about the future, is that it can scale potentially up to 64 terabytes of storage. The thing is, of course, the moment that you move towards Aurora, you're also pushing yourself inside a certain choice. So maybe at this point, it's also important to take a step back and rethink, okay, well, what will I actually do with my database? Should I use another scaling solution to make sure that well, my database remains performant, etc. Especially if we're talking about these types of sizes. So, okay, that's an error. Anyway. Okay, so an example architecture I've just shown. I wanted to show it to you a little bit. So the idea is indeed that in a way it's communicating with this local object store, and it's replicating the data directly to the data store from the master. So you have cluster endpoint, which is used for all the read and write queries, and you have a reader endpoint, which is only used for the read queries. So the system itself is actually trying to maintain consistency. So there is a verification on the storage level to make sure that it's consistent itself. Of course, what is the negative part of it? If you have specific corruptions on the storage level, you don't really have an ability to verify, for example, how you can potentially recover your data. How can you migrate to Aurora? That's fairly simple, right? So the moment that you have RDS, it's fairly simple. So you create an Aurora read replica. At that moment, it will actually create an Aurora cluster in 3 availability zones. So at that moment, it will try to get up to date. And at that moment, the endpoint, you can actually modify the endpoint on your application and point it towards your Aurora cluster. For external databases, so there is actually a procedure available provided by Amazon, which is based on Percona Extra Backup, in which that you actually perform a backup locally on the on-premise machine, which is a non-locking backup, and then push it towards an S3 bucket. At that point, Aurora can import the raw files inside its object store. The only thing that you will have to keep in mind is that you will have to recreate user accounts, functions, store procedures, and that your system needs you need to be able to let your application go down for, well, depending on the size of your environment, for a considerable amount of time. Because there's no replication process for external databases at this point, and as far as I know. So Amazon Aurora, why should you use it or not? And this is my opinion at this point. So I think it's a distributed storage solution. So in my opinion, it will work. It works quite well. It's quicker in write-heavy workloads. And the good thing is, because you're not basing yourself on a synchronous replication in between the nodes, but on communicating redo logs, you don't need your replication systems will have less work actually. So you have a different type of consistency model. It's also, well, it's relying on another technology. Um, why shouldn't you use it if you currently only have in-memory workloads, which means that, well, your data set fits completely in memory. Um, you don't, or also if you have only read-heavy workloads. In my opinion, what is important though is that at the moment that you move towards a solution like Aurora, it's not open source, right? So it's not something which is available. It's like a black box. So it is potentially you will lose visibility. It's also not easy to migrate away from it, right? So moving away from it potentially is problematic. So keep that in mind before taking the choice to go towards Aurora, is that you probably have to stay within it, except if you're going to dump and restore your data. Something that covers all systems right now, so everything in regards to Amazon, Aurora, well, in general AWS, but also EC2 machines, etc. Make sure that your AWS instances are secure. You're on the public cloud now, so that means that you have to create decent security groups. You need to limit the servers that are able to connect to your databases, for example. You have to make sure that you perform decent user management. It's another ball game the moment that you move towards a public cloud solution. So make sure that you're that you're 100% focused on making sure that your system are secure externally. Also, whenever you're connecting to the Amazon web console, make sure that you're using the IAM service for accessing your infrastructure. It's much more secure. It's also you can see who logged into it. You can limit the amount of rights that your users have, and there's actually a very interesting white paper available from Amazon, which actually defines the best practices in regards to AWS. So after this short webinar, I just want to summarize it a little bit. In my opinion, what your choice should be, right? So in my opinion, EC2 gives you the most flexibility, right? So you have it's a compute solution. It gives you the ability to create your own solution. Of course, you need to manage it. So if you want some managed solution which is very stable, RDS might be the essential part. Keep in mind that it's tuned for general workloads, so it's focused, of course, on a general consensus of what Amazon workloads exist of. So you can still tune it using your parameter groups, but it will be much more limited than using Percona Server, MariaDB, or MySQL. Aurora itself is very interesting if you have a really write-heavy workload. So if it fits in your use case, and if you can handle the fact that you're potentially not inside a complete open source solution. Migrating towards Aurora there, on the other hand, at this point, especially from external server, is potentially something which is much more difficult. So keep that in mind the moment that you're choosing to move towards the AWS infrastructure. On the other solutions, actually migrating towards it is quite easy if you keep in mind, for example, that you lose super privileges, that you need to make sure that you test it properly. I cannot enough emphasize it, and that you're able to cope with working with the Amazon Web Console and CI. So that's it from my end. I will be available at Percona Live. So I'm delivering a tutorial, a complete day tutorial there. So feel free to join us if you're interested. Emily will give you some more information about it right now. And it's coming up in April 24th, and it's a 4-day conference.
Yeah, thank you so much for that, Dimitri. As a friendly reminder, Percona Live is fast approaching, and we'd like to offer you 15% off to join us in Santa Clara, California. Just use the code WebinarPL. Also, we have some sponsorship opportunities available as well. If your company is looking to hire, we have some recruiting pavilion options. If you're looking to just do something virtual, we have some bag insert options as well. So check it out. And we hope to see you at this year's conference. Also, at this time, we'll also take some of your questions. Go ahead and enter them in the questions field down below. And as a friendly reminder, any of them that weren't answered will be addressed in a follow-up blog entry on Percona's database performance blog. So with that said, I will start it off. Dimitri, is there a size limit for MySQL or MariaDB tables in RDS? I remember reading that Aurora had a limit of 3 terabytes.
Yes, I don't know them by heart, but I can make sure that I confirm them on the blog post. So I'll make sure that that's confirmed. So, that I send out, for example, some links on where you can verify them themselves. But yes, there are size limits, as in MySQL itself, also, of course.
Great. Let's see. Our next question is there a possibility to get CET time zone um, at a host if we choose on-premise hardware since AWS has DCs in Europe, Ireland, Frankfurt, London, etc., please?
As far as I know, not no. So there's always local storage because it's using internal storage. As far as I know, everything is UTC.
Um, do you happen to have any benchmark results of EC2 versus like RDS 5.7 versus Aurora?
We have some benchmark results, but not on 5.7 as far as I know. I will also make sure that they're included in the blog post that I make so that you can have some links. I have some interesting documentation, so I will make sure that those are all available to you guys. Also through the blog post, I will list them up, or I will send them to Emily.
Um, let's see. It was mentioned earlier on the UTZ time zones when migrating to RDS. What type of issues will we face if we were using other time zones?
So what you have to keep in mind is that if you're using other time zones, your functions will, for example, work differently. So it all depends a little bit on how you. In my opinion, it's the best practice that you have the UTC time zone right now. There's no really a reason why you should use it, in my opinion, anyway. Um, it will give you potential issues with applicative communication afterwards, specifically when you, for example, want to already move your read queries towards that system, for example, your new RDS infrastructure, while not already having changed the write queries, it could give you issues.
Okay, our next question is, we have an application which we are planning to move AWS to Aurora. In our application, we are using OutFile to save informations from the table to CSV files. Aurora does not support it. Is there any workaround or a different way to do this so we can save the files? Also, do you suggest any other solutions in order to do this?
Um, that's a good, interesting question. I don't have that edge case myself at this point, but I will verify internally because we have a lot of customers who are using Aurora, what their potential solution might be for it, and also if they have a specific workaround for it. And then I will confirm that also again in the blog post. I think that might be an interesting topic already to discuss.
Okay, let's see. Our next question is, thanks so much for the great webinar. Do you think the future of managed service providers with focus on database operations will soon be based on elastic or pre-prepared infrastructure as a service like AWS can offer. Also, can it possibly be a combined offer for most of the managed services providers things?
Well, so yeah, I think in a way it's a very interesting solution, right? So it's providing people with easy access, but of course it doesn't cover query optimization or for example, table schema optimizations, etc. So still from that level, it's still something that you still need to do yourself. And so I still think that on managed services standpoint, there is still um, there is still let me try to find my words. I'm a Belgian, so Dutch is my native language. So there is still, how you call it, a value to having managed services even with RDS, because people will still need to optimize their queries, modify it. How I see the future combined, I don't know. In my opinion, for example, RDS is a very valid technology, very, very mature already. But, if there is still a lack of flexibility, right? So and if you need that flexibility as you're in your team, you're still, well, you potentially still need to focus on EC2 or on-premise hardware. And at that moment, managed services again becomes much more interesting the moment that you need somebody to maintain and operate your system. So I don't know. I think it will remain something which is separated in a way in the future. But it depends. I think RDS has, well, grown significantly, right, in the last 8 years. So I think it's a really valid technology. So I don't know what the future specifically will bring, but in my opinion, everything will stay. Well, it will remain a parallel road. If that explains it a little bit.
Yes, yes, it does. um, let's see. I'll try to give you. Let's see. How about using proxy SQL or another proxy tool in Amazon environment? Any advices?
So as far as I know, the one that I've worked in myself in the past was always ELB or the cluster or the endpoints themselves for RDS. So especially inside RDS, I don't really know if there's added value in using. Potentially, it could be in front of it, right? So that your application is pointing to proxy SQL and that you actually filter or do transparent filtering of your read and write queries depending on the other endpoints or to the read replicators, uh, the read systems. Oh God. Um, Afterwards, so next to proxy SQL itself, so ELB is often used, or HA proxy is often used just to separate, for example, the write and the read queries. But the thing is, of course, what you have to keep in mind, if your application is not able to move its read queries towards separate instances, at that moment you need something which is potentially transparent on that hand. And then proxy SQL would definitely come into play, or MaxScale for that, depending on what you want to use. So in my opinion, it would definitely work. How it would be implemented specifically for RDS, cannot really answer that correctly at this point.
Okay, and let's see. I'm going to try to squeeze in one more question, and
Yes,
then go ahead and continue to submit questions. I'll make sure to send all of these to Dimitri after the webinar so that he can answer. Um, so, with that said, our last question will be: do you have any take on AWS DMS for migration to RDS?
data migration services. Not myself, no. It's a very shiny new, well, again, new announcement to it. Well, it's new. It's been a year, or even more. But I think it's definitely interesting, specifically if you're coming from an other technology standpoint. What the underlying technology is, I'm not 100% sure at this point, but I think it's really valid if you're moving away, for example, from a proprietary solution towards RDS. What you have to keep in mind, of course, is that if you want to use, for example, Microsoft SQL is available, so SQL Server is available also in RDS, and also other vendors. So it depends where you want to move away from and move towards to, in my opinion. So that would really, well, that would really depend if you would need DMS itself or not, if you want to move away from an existing technology. But how it specifically would work out, I would definitely need to look deeper into it.
Okay, great. Well, thank you so much for that. Thank you so much, everybody, for attending today's webinar, and a huge thanks to you, Dimitri, for presenting today. And please enjoy the rest of your day, guys, and we hope to see you on our next webinars.
Thank you, guys. Have a pleasant one.